Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome back again to my channel. Okay, so today we are going to learn a new chapter, which is chapter 5 in Hibbeler book. And the topic is equilibrium of a rigid body. Okay, so in this new chapter here, you will learn about the support reaction. Okay, how to determine the reaction, whether we have force or not. So in which direction is the force, x, y or z. Okay, and also we will learn about the reaction moment. Okay, we will look at moment also, so we will see whether it will create a moment or not. Okay, whether we have a reaction of moment or not. Okay, and after we've learned about the support reaction, we will use moment 3D, okay, R cross F, to calculate the reaction force or reaction moment, okay, using R cross F. Okay, so let's look at how to determine the support reaction. Okay, so as you can see here, okay, I put 3 examples here, which is cable, okay, this one, cable, weightless link, okay, this is a link, okay, weightless, and also a roller. Okay, so each of this part here, okay, of this support here will have a reaction. Okay, for example, just like this cable here. Okay, if we try, okay, for this cable here, if we try to pull this one, okay, this thing here upwards, okay, this cable will prevent it from moving upwards. Okay, and like this one also, weightless link, if we try to put a force here, okay, let's say we put a force in this direction here, so this thing here will not move because we have this link here. Okay, and for this roller here also, okay, this thing, if we push down like this, okay, in this direction, okay, so this roller will not move downwards, okay, because it will have a reaction. Okay, so we will look at how to determine or how to draw the reaction, okay, that I've been talking about. Okay, so to make it easy, okay, I summarized it into this flowchart. Okay, so can you see the flowchart? Okay, so when you want to determine whether the force or the moment will be created or not, okay, the reaction, reaction force and also reaction moment, you need to consider this one. Ask yourself, can it move or rotate in this specific direction? Can or not? If the answer is yes, yes, it can move, so means that it will not have any reaction force or reaction moment. Okay, if it is rotate lah, if it can rotate, so no moment. If it cannot move or cannot rotate, so we will have a force, a reaction force or a reaction moment. So ask yourself, can we move it or not? If yes, means that no reaction force. If the answer is no, means that it will be a reaction force. Okay, so let's look at this cable first. Okay, as I mentioned earlier, if we apply this force like this, okay, this cable will prevent these things from moving upwards, correct? So can it move or not? The answer is cannot. So cannot move means that it will have a reaction force. Okay, so what is the reaction force? Let's put blue color. Okay, so the reaction force will look like this. Okay, downwards like this. Okay, and next one, this one, weightless link. Okay, if we put a force in this direction, can this thing move or not? Cannot. Okay, so cannot means that we will have a reaction force. Reaction force must be opposite direction with this one. So reaction force is pointing upwards. Okay, so reaction force is something that when we, okay, for example, when we push like this to make it stop, another force we need to push like this back to prevent it from moving. So that's why when a force is applied in this direction, we will have a reaction force pointing towards opposite direction, which is why this one, so direction is here, so the reaction force must be here. Okay. And what about the roller? Okay, roller here, as I mentioned earlier, we cannot push this this rod downwards like this in this direction. Cannot. Okay, because we will have a reaction force. Okay, so these three are the reaction force. This one, and also this one. Okay, easy kan? I think for me it's very easy. Okay, just ask yourself whether we can move it in this direction or not. Okay, so for example, okay, like roller, okay, roller means that something we can move freely lah. Okay, so roller here we can move it freely in this direction. Okay, so because we can move it freely in this direction, can we move it? Yes. So if the answer is yes, means that no force in this direction. That's it. Okay. Okay, let's try to look at another support. Okay. Okay, let's look at this one. Okay. Cable I already mentioned Cable. Okay, we will have a reaction force in this direction. Okay, along this cable here. Cable here, if it is cable, it can only be in one specific direction only, outwards. Okay, this cable here cannot become inwards like this. Okay, cable cannot. Okay, cable must be pointing outwards. Okay, and then this one, smooth surface support. Okay, for the smooth surface support here, we can move this rod here freely in X direction, okay, Y direction, this one, okay, Y direction, but we cannot move it downwards. Okay, Z direction cannot. Correct, Okay, Z direction here cannot, so means that we will have a reaction force opposite direction, okay, than the Z direction. Okay, so that is why we have a reaction force pointing like this. What about a roller? A roller also, okay, roller can move freely in X direction. Okay, can. Y direction, can or not? Can, okay, X and Y move it freely, but still roller cannot be pushed downwards. Okay, downwards cannot, downwards here. Z direction cannot. Okay, so means that is why we have a reaction force pointing upwards in Z direction. Okay, easy, Okay, next, let's take a look at ball and socket, and also let's think about moment also. Okay, so this one here we only think about reaction force. So let's take a look at this one. Ball and socket. Okay, for ball and socket here, this one. Okay, we have X, we have Y, and also we have Z. Okay, ask yourself, can we move this ball here in X direction? Can or not? The answer is cannot. So if the answer is cannot, means that we will have a reaction force in X direction. Okay, same for Y. Can we move it in Y direction? This direction? Can or not? Cannot. So cannot, that's why we have Fy. Okay, what about Fz? Can we move it in Z direction? Pull it like this or push down like this? Cannot. Okay, so cannot. So cannot here, which is why we have Fz. Okay. So what about rotation? Okay, look at this one. Okay, the flow chart again. Can it rotate in x direction? If yes, no moment. If no, means that we have a reaction moment. Okay, let's take a look at this ball and socket. Okay, for ball and socket, this one x direction. X direction means this one. X direction is this one Okay, so this is x direction, and this is the rotation. The direction of your rotation Can we rotate like this or not? This one, rotate like this or not? For ball and socket, the answer is yes. Okay, we can rotate this bar here like this. Okay, like this. So means that we don't have moment, reaction moment. Okay, if we can rotate, means that no moment. Okay, so that's why no moment. Okay, what about y direction? So y direction is pointing like this. Correct Pointing like this. So the rotation is supposed to be like this. So can we rotate like this or not? Okay, the rotation. Can Okay, ball and socket can. We can rotate it like this. So means that we don't have any reaction moment in y direction. What about z? So z here like this. So rotate like this. So means we want to rotate. Rotate like this Still we can because this is ball and socket. So means that we don't have any reaction moment. That's it. Very simple Okay. What about this one? Single journal bearing. Okay. Look at this carefully Okay, let's draw x, y, and z axis first. Okay, so at this point here, we have x, and this one we have y, and upwards we have z. Okay, so let's take a look at force first. Can we move this rod here in x direction? Can or not? Can or not? Push like this. Cannot. So cannot. So which is why we have Fx. The reaction force Fx. Okay, what about z direction? Can we, this one can we push it like this? Push it upwards or downwards? Can or not? Cannot. So cannot means that we have reaction force Fz. Okay, what about y direction? Can we move this rod in y direction? The answer is yes. Okay, this is single journal bearing. So means that it can move freely in y direction. So because it can move freely, yes, it can move. Therefore, no reaction force. Okay, no reaction force will prevent this this rod here from moving in y direction. So which is why we don't have any reaction force in y direction. Okay, what about moment? Okay, for x direction. Okay, so x direction, the rotation should look like this. Okay, can we rotate this rod in this direction? Can or not? The answer is cannot. We cannot rotate like this. So cannot. Therefore, we have reaction moment. Cannot have. Can, don't have. That's it. So in z direction also, we cannot rotate it like this. Okay, z direction should be a rotation like this. Okay, we cannot rotate it like this. So which is why we have reaction moment in z direction. Okay, what about y? Okay, as you can see here clearly, okay, this rod here is actually a circular rod. Okay, circular rod. So if in y direction, correct y, okay, correct okay, so it can rotate freely. Okay, because this is a bearing and also this is a cylinder rod, so it can rotate freely. So which is why we don't have any reaction moment. Easy, very easy. Okay. Okay. So based on my explanation here, okay, please take a look at the others connection here. Okay, which is connection number 6, connection number 7, connection number 8, connection number 9, and also connection number 10. Okay, try to think it by yourself. Okay, ask yourself whether we can move it freely or not in X direction, Y direction, Z direction. If we cannot move, means that we will have a reaction force. Okay, so then ask again yourself whether we can rotate it in X direction, Y direction, or Z direction. If we cannot rotate, means that we will have a reaction moment also. If we can, we don't have any reaction moment of force. Okay, so that's it. So try to look at this other 5 connection here. Try to think and try to understand why the reaction is like this. Okay, for the force and also for the moment. Okay, so if you have any question, feel free to ask me. Okay, don't be afraid. Okay, so see you again in the next video. Bye bye.